Hello friends, continuing with the topic of radioactivity, today we come to another part of it, two common time measures. What are these two common time measures? First is half-life and second is mean life. First we take up half-life of a radioactive element. Definition of half-life: the time duration in which the number of atoms of a sample of radioactive element reduced to half of its initial value, or the time at which both N and R have been reduced to one half of their initial values, where R is rate of disintegration. It is denoted by T half. I repeat, the time duration in which the number of atoms of a sample of radioactive element reduced to half of its initial value, or the time at which both N and R means rate of disintegration, have been reduced to one half of their initial values. It is denoted by T half. Now, since we know Nt is equal to N0 into e raised to power minus lambda t, mark it as equation 1. Now, when t becomes T half, then Nt becomes N0 by 2. Let us mark it as equation 2. Now, from equation 1 and 2, we have N0 by 2 is equal to N0 into e raised to power minus lambda t half, or e raised to power minus lambda t half is equal to 1 by 2. Let us mark it as equation 3 because N0 cancels here. Now, taking log of both sides of equation 3, we have log e raised to power minus lambda t half is equal to log 1 by 2, or minus lambda t half is equal to log 1 by 2, or t half is equal to minus log 1 by 2 divided by lambda. Minus log 1 by 2 we can write it as log 2 divided by lambda, and it is equal to or t half is equal to minus log 1 by 2 divided by lambda, or we can write it as log 2 divided by lambda, or we can write it as 0.693 divided by lambda because the value of log 2 to the base e is 0.693. Therefore, t half is equal to 0.693 divided by lambda. This is how we can derive the expression for half-life. T half is equal to 0.693 by lambda, where lambda is disintegration constant. Now, assignment 13 continued. Question number 23. Define the following in case of a radionuclide: half-life, disintegration constant. Question number 24. Obtain a relationship between half-life and disintegration constant. Question number 25. Define the term activity of a radioactive substance. Two different radioactive elements with half-lives T1 and T2 have N1 and N2 undecayed atoms respectively present at a given instant of time. Determine the ratio of their activities at this instant. Question number 26. Prove that the instantaneous rate of change of the activity of a radioactive substance is inversely proportional to the square of its half-life. Question number 27. Determine the amount of polonium in kgs necessary to provide a source of alpha particles of 5 millicurie strength. The half-life of polonium being 138 days. Question number 28. the half-life of uranium-238-92 against alpha decay is 4.5 into 10 raised to power 9 years. How many disintegrations per second occur in 1 gram of uranium-238-92? Now, let us try to understand about the fraction of a sample left after time t. Since we know during first half life the fraction left would be Nt by N0 is equal to 1 by 2 raised to power 1. During second half life fraction left would be Nt by N0 is equal to half square, and during third half life it would be half cube, and so on, and during nth half life it would be half raised to power n, that is Nt by N0 will be equal to 1 by 2 raised to power n. Now, total time taken during n halves lives, say t is equal to n into t half, or n would be equal to t divided by t half. Therefore, fraction left after time t would be Nt by N0 is equal to half raised to power t divided by t half. Okay, I repeat. Therefore, fraction left after time t would be Nt by N0 is equal to 1 by 2 raised to power t divided by t half. Now, assignment 13 continued. Question number 29. Tritium H31 or T31 has a half-life of 12.5 years against beta decay. What fraction of a sample of pure tritium will remain undecayed after 25 years? Now, question number 30. After certain lapse of time, the fraction of a radioactive polonium undecayed is found to be 12.5% of its initial quantity. What is the duration of this time if half-life of polonium is 138 days? Question number 31. A radioactive material is reduced to 1 by 16th of its original amount in 4 days. How much material should one begin with so that 4 into 10 raised to power minus 3 kgs of material is left after 6 days? Question number 32. Prove mathematically that fraction Nt by N0 of a radioactive element left over after a time t equals 1 by x, where x is equal to 2 raised to power t divided by tau, where tau denotes half-life period of a radioactive element. And now, mean life of a radioactive element. Let us try to understand the definition of mean life. The time at which both n and r have been reduced to e raised to power minus 1 of their total value, and it is denoted by tau. I repeat, the time at which both n and r have been reduced to e raised to power minus 1 of their total value is defined as mean life of a radioactive element, where r is rate of disintegration. It is denoted by tau. Mathematical expression. Rate of disintegration is given by the expression r is equal to dn by dt, which is directly proportional to nt, where nt is number of atoms present at that instant of time. Or we can write dn by dt is equal to minus lambda nt, where lambda is disintegration constant and minus is for reduction in number of atoms with time. The number of nuclei which decay in interval t to t plus delta t will be equal to r into delta t, and r delta t is equal to dn, which is equal to lambda into nt into delta t. Now, substituting the value of nt is equal to n0 e raised to power minus lambda t in above equation, we have r delta t is equal to dn is equal to lambda into nt into delta t, and it is equal to lambda into n0 into e raised to power minus lambda t. Now, mean life of a radioactive element continued. Each of them has lived for time t. Thus, total life of these nuclei would be T into dn, which is equal to T into lambda into n0 into e raised to power minus lambda t. Some nuclei may live for short time while others may live longer. Therefore, to obtain the mean life, we have to integrate the expression over all times from 0 to infinity and divide by total number n0 of nuclei at t equal to 0. Therefore, we have tau equal to lambda into n0 integration 0 to infinity t e raised to power minus lambda t into dt divided by n0, or it is equal to lambda integration 0 to infinity t into e raised to power minus lambda t dt, and it is equal to 1 by lambda. After integration, we find that it is equal to 1 by lambda, or tau is equal to 1 by lambda. Thus, mean life is also defined as reciprocal of disintegration constant. Now, alternative definition of mean life. It is the average time for which an atom of a radioactive substance exists. It is given by the average of the lifespan of all the atoms of the radioactive element. Mathematically, it is the ratio of sum of the lifespan of all the atoms of a radioactive sample and the total number of atoms in the sample, and is expressed as tau is equal to 1 by lambda. I repeat, it is the ratio of sum of the lifespan of all the atoms of a radioactive sample and the total number of atoms in the sample, and is expressed as tau equal to 1 by lambda, where lambda is disintegration constant. Thus, mean life is defined as reciprocal of disintegration constant. I repeat, mean life is defined as reciprocal of disintegration constant. Now, relation between mean life and half-life. Since we know mean life is given by the expression tau is equal to 1 by lambda and half-life is given by the expression 0.693 by lambda. Therefore, we have tau mean life is equal to half-life divided by 0.693. From these two relations, we can easily find that mean life tau is equal to half-life divided by 0.693. Now, assignment 13 continued. Question number 33. Define mean life of a radionuclide. Obtain an expression for it. How is it related to half-life? Okay. So, here we finish with this chapter of nucleus and the topic of radioactivity. Thank you so much. Next time we'll start with the next unit, semiconductor and electronic devices. Till then, goodbye and good luck to you.